Thousands of years ago, Greek philosophers proposed a thought experiment. Imagine taking an apple and cutting it in half, then cut that half in half. Keep cutting it down to smaller and smaller pieces until you reach a speck of matter so infinitesimally tiny that it cannot be divided any further. They called this ultimate indivisible limit an atom. It was a pure mental abstraction, a logical baseline needed to explain the physical universe, long before anyone had the tools to actually see it. By the 20th century, scientists finally had those tools, and they believed they had the structure mapped out. They modeled the atom as a microscopic solar system, with tiny electrons orbiting a dense central core, exactly the way planets orbit the sun. But that intuitive mechanical picture is wrong. When you zoom down to the quantum scale, the planetary model completely fails. To understand the actual materials that construct our universe, we have to abandon our everyday experience of solid objects and accept a highly unpredictable subatomic logic. That subatomic structure is built entirely from three fundamental ingredients: protons, neutrons, and electrons. Out of these three, the proton has a specific foundational job. Its exact quantity acts as a definitive identity badge for any element. We call this the atomic number. A cluster of 6 protons forms carbon. Add 2 more and it becomes oxygen. This vintage periodic table shows that organizational logic in action. The numbers printed in the corners of the element boxes indicate the exact proton count required to create each specific element. By adding or subtracting a single proton, the universe mathematically conjures entirely different physical substances, determining whether matter behaves as a breathable floating gas or as a dense, rigid metal. While protons dictate an element's identity, physical weight is determined by the mass number. This accounts for the heavy protons and neutrons locked tightly inside the atom's center, the nucleus. The orbiting electrons are ignored in this calculation. A single proton weighs roughly 1,836 times more than an electron, rendering the electron's weight practically irrelevant. Identity strictly follows protons, but an element's weight can vary. Packing extra neutrons into a carbon nucleus creates a heavier isotope. Zooming out, those lightweight electrons don't trace neat circles. Instead, they exist as a hazy probability smear called an orbital. At this extreme scale, our everyday intuitive concept of a solid physical particle completely breaks down and dissolves. Instead of solid matter at a specific point, an electron is a mathematical distribution, described only by where it is most likely to be found. Looking at the completed model, we have a dense microscopic nucleus locked at the center of a vast, unpredictable electron cloud. The discrepancy in scale between those two components is immense. The nucleus occupies only about 1/10,000th of the total volume of the atom. Think about the objects you interact with constantly: your hands, the walls of your room, the screen displaying this video. Because of that massive void between the core and the electron cloud, 99.999% of all matter we perceive is completely empty vacuum. We perceive these objects as solid, not because they are packed with matter, but because the electric forces repelling those vast clouds of electrons are strong enough to resist our touch. Our reality is a world of invisible forces acting across an overwhelming void.